Okay, in this experiment we're finding out how to neutralize an acid. We're using the acid hydrochloric acid, and I've put some of the colorless hydrochloric acid in this beaker, and I've added to the beaker an indicator, pH indicator solution. This solution is similar to the paper strips we used last week, and you can see that depending on the pH you'll get a different color. So pH 4 is red, neutral is green, and more basic is sort of purple. What I'm going to do to neutralize this acid is I'm going to be adding a base. And as I add the base, we should get some different color changes. You can see the color will change. Still got some red, but if I continue to add the base, okay, so I've got, right now, I've added enough base, so we're at probably about pH 5.5. And if I slowly add the base, whoops, that might be a bit too fast. Might probably added a little bit too much there. Now it seems I've gone past the neutral, so I'm probably close to 9. And if I want to go back, then I need to add a little bit more acid. Okay, let's see if I can do this. And add 1 drop at a time to get, that's fairly close to 7. So 7 is neutral, and it looks like we have a neutral solution. So to neutralize an acid, we need to add base. And if we start with a base, to neutralize a base, we need to add an acid. Now, why is it possible to neutralize an acid with a base? Well, an acid, all acids contain the hydrogen ions. And an ion is anything with a charge. In this case, we have a hydrogen with a positive charge. So all acids contain hydrogen ions. All bases contain hydroxide ions, OH minus. In this case, the charge is negative. When you put an acid and a base ion together, you end up with water, and the pH of water is neutral. So acid and base in the right amount make neutral. Now, in our experiment, we used sodium hydroxide. So here we have our hydroxide ion, this is our base, and we used hydrochloric acid. Again, we have our hydrogen ion, which is an acid. When you put these together, we get water, which is neutral, and salt. So you could theoretically take a very, very strong base, a very, very strong acid, and if you neutralize them perfect, you would end up with salty water, which you could drink. Okay, in our last experiment, we used this indicator to tell us. An indicator means it's going to tell us if we have an acid or a base present. So we use this indicator. But this experiment, we're going to use an indicator that we're going to make ourselves with red cabbage, and this is just a bit of red cabbage. We put some of the leaves of the red cabbage or purple cabbage into water, and we boiled the water up, and we got this sort of purpley liquid. A bit hard to tell on the camera, but it's a dark purple liquid, and we threw the leaves away. Now this acts as an indicator. This is the color it goes if we add a strong acid. This is the color it goes if we, on the right, if we had a weak acid. So a little bit of a change. Neutral, if we add water, it's a sort of slight bluey purple color. Weak base, it's more of a greeny color. And strong base, it's a yellowy green color. And then we had 2 unknowns. We had unknown number 1. And if you compare unknown number 1 with a strong acid, you can see that the unknown 1 was a strong acid. And our other unknown, if you look at the bottom, you can see very similar, sort of yellowy green. Unknown number 2 was a strong base. So we can use our homemade cabbage water as an acid-base indicator. You can use this at home. Boil up the cabbage with some water and test any chemicals at home and look at the color. And lastly, we got the alcohol out of our wine. So to make our wine, if you remember, we took grape juice and yeast. And the grape juice eats the sugar of the yeast and it spits out carbon dioxide and alcohol. So I put this liquid into this container here. So inside the liquid, we've got the yeast at the bottom, we've got some grape juice in there, we've got some water, we've got alcohol. I then heated it up, and what happens is the alcohol has a lower boiling point than water. So the alcohol, when you heat it up, comes up here as a gas, and then it hits this tube. This tube is cooled by water, so the alcohol gas condenses back into a liquid, and that liquid collects here. So I'm not going to demonstrate it now, but we did this in class. We collected the alcohol. We showed it was alcohol by burning it. So the way this works is that because there are different boiling points, the alcohol will evaporate first when you heat it, and it will condense back on this cold tube and be collected before the water boils.